Good evening. Several interesting news items this month. The Galileo spacecraft, on its way to Jupiter, has sent back a new photograph of the asteroid Ida, an irregular, small, cratered world. And look over to the right there. You will see a small point of light. And that is a satellite of Ida, about 1.5 miles across. And this is the first time we've ever definitely recorded a satellite of an asteroid. And then, of course, there's the new American lunar probe, Clementine, launched, first of all, into Earth orbit, and then put into a path around the moon, and sending back very good pictures. Some are extremely sharp. Particularly, it's been photographing areas near the moon's south pole, where there are some craters where floors are always in shadow, and which are very cold indeed. And there have been reports that Clementine had detected ice. Now, I'm rather dubious about this, frankly. The moon doesn't seem to be the kind of world where ice would be expected, and the rocks analyzed by the Apollo astronauts and the Russian lunar probe so far have shown no sign of hydrated material. So I reserve judgment. We've merely got to wait and see. Another very interesting discovery is that of a new dwarf galaxy in the constellation of Sagittarius. It's not very obvious, but it's very close, about 80,000 light years away, and that's far nearer than any other external galaxy. It's not easy to recognize. It's being disrupted by our galaxy, and it won't survive indefinitely. But meanwhile, it has set a new record. And now, on to our main theme this evening. On May the 10th, we're going to have a partial eclipse of the sun. What will happen is that the new moon will pass between the sun and the Earth and blot out more than 50% of it as seen from England. This, of course, is very much speeded up. The further north you go, the less you'll see. From Spain, more than 80% of the sun will be hidden. From the Channel Islands, nearly 60. From London, just over 50. And from Scotland, just less than 50. And that line over to the middle of the picture represents the sunset. And if you go further east of that line, the sun will be below the horizon, and you won't see anything at all. Let me give you then a timetable. And I think I'd better give you these in summertime. And this is going to be an afternoon eclipse, so the sun's going to be very low by the end of it. It begins, May the 10th, 6:35 p.m. summertime, greatest obscuration 7:35, and the eclipse ends at 8:30. Of course, those times do vary very slightly over various parts of Britain, but not appreciably. The old Chinese had very strange ideas about eclipses. They believed that a hungry dragon was trying to gobble up the sun, and the only answer was to beat gongs and bang drums and shout and scream and make as much noise as possible in order to scare the brute away, and of course it always worked. Well, we know rather better. The Earth goes around the sun, the moon goes around the Earth, and therefore there are times when the three bodies line up with the moon in the mid-position. When that happens, the moon shadow just touches the Earth, and we have a solar eclipse. But this doesn't happen every month, because the moon's orbit is tilted compared with ours, and therefore, at most new moons, the sun avoids eclipse. Sometimes the new moon passes unseen above the sun in the sky. We're showing it to you there. In the sky, of course, it's quite invisible. If the alignment is correct, then we do get a solar eclipse. There we are. At other times, the moon passes unseen below the sun in the sky, and once again, there's no eclipse. But these eclipses are interesting to watch. At this stage, I'm delighted to welcome back our photographic and eclipse expert, Douglas Arnold. Douglas, it's going to be interesting, isn't it?
Yes, Patrick. In a total eclipse, for a few minutes, and it's never more than 8, we can see the surrounding regions of the sun. There's the red chromosphere, the masses of glowing gas that the Victorians once miscalled the red flames, and which we call prominences, and of course there's the beautiful pearly white corona. It really is a glorious spectacle, and I don't think there's anything in nature to compare with it.
I absolutely agree, but this eclipse, sadly, is not total over here. In fact, this one is not total anywhere. Eclipses are the three kinds because the moon's path around the Earth is not a perfect circle, and the distance from us can range between just less than 222,000 miles out to a bit more than 250,000 miles, and that makes quite a difference to the apparent size. Now, by sheer coincidence, the Earth and the sun and the moon appear almost the same size in the sky. The sun is 400 times bigger. It's also 400 times further away. But when the eclipse happens, when the moon is in the far part of its orbit, then the moon appears smaller than the sun and is not quite big enough to cover the sun completely. So this is what happens. The invisible body of the moon is surrounded by a ring of sunlight. Now, the Latin for ring is annulus, and therefore we call an eclipse of that kind an annular eclipse. You can't see the corona or the prominences, but nevertheless, it's interesting. You took a lovely photograph some time ago, Douglas.
Yes, this was taken in California in January of 1992, Patrick. We weren't directly on the central line, so you can see the annularity is a little ill-balanced, but nonetheless it is complete. And I should stress, you're absolutely right, of course, that with an annular eclipse you can't see any of the corona. What we're seeing in this picture is the sunlight shining through clouds of a storm cloud which was coming down from the north.
Well, I've seen one annular eclipse some time ago from the Greek Island, and I was on the central line, and I took a series of pictures. That's well before annularity, and here the almost annular, and finally a lovely ring of sunlight round the eclipsed moon. A most quite spectacular sight. Now, this coming eclipse of May the 10th is annular over various parts of the world. In fact, the track of annularity crosses the North American continent, and then it crosses the Atlantic. It ends just on the tip of Africa. And if you look down to the bottom left of the picture there, you can see the end of the annular track. And the further north you go, the less you'll see. And as we said, over England and Scotland, we have a partial. There's one other rather interesting thing to look out for, too. To some extent, the sun is a variable star. Every 11 years, it's active with many of the dark patches we call sunspots, and then activity dies down. At the moment, we are near solar minimum. And there may be many days when there are no spots at all. They are not entirely absent. This picture was taken by Douglas last January, and there were several spots there. But when I made a drawing of the sun only a few days ago, there were almost no spots at all. And whether there are going to be any spots at the time of the eclipse, we don't yet know. But one thing here I must stress. The sun is a dangerous object. It's bright, and worse, it's hot. Don't look at the sun through any telescope or pair of binoculars, even with a dark filter, unless you really know what you're doing. If you do, you may burn your eye out, and this happens, so please bear that closely in mind. Don't use things like photographic negatives and bits of ordinary smoked glass. If you want to see sunspots or project the eclipse, there's only one sensible way to do it, unless you're an expert. Take a telescope, point it at the sun without looking through it, and then hold a screen behind the eyepiece. And if you do that, you'll see any sunspots quite well. And sunspots may be compared with the moon's body on the sun.
That's right, Patrick. If you look at this picture, the moon's disk is very, very dark. We talk about dark sunspots, but you can see the comparison here. They aren't, in fact, dark. They are about 2,000 degrees Fahrenheit lower in temperature than the surrounding area of the solar photosphere, and so it's a comparative effect. If we could transpose these sunspots to the surface of the Earth, they would be brighter than arc lamps, for example.
Well, whether there are sunspots or not, this partial eclipse is going to be well worth seeing and well worth photographing. Douglas, will you give us all some tips?
Yes, that's true, Patrick. I think the most important thing to stress is your point about the safety. You can look at the sun through instruments, you can photograph it, but only if you have, directly, if you have the correct filters. Now, I have two here today. There is, first of all, an Inconel type filter. It's so called because it's a metal alloy on glass and it's composed of iron, cobalt and nickel. Now, the delight of this one is fairly expensive, but the pleasure and delight of this one is it gives you a natural coloured sun, as we can see here. There's another type of filter which is a form of plastic sheeting. It is about the same price, actually, when it's mounted, ready for going on lenses. It's mylar, aluminized mylar, just as safe, just as effective. The problem with the mylar, at least as far as I'm concerned, is it gives you a rather exotically coloured sun, which is blue, and the sun never looks right when it's blue to me, but that's by the by.
I totally agree.
Now, the second thing, which is very desirable, concerns the focal length of lenses. Now, there's a rough rule of thumb which says that if you divide the focal length of your lens by 100, that's not really right, it should be 110, but it's much easier to divide by 100, at least it is for me. If you divide by 100, the figure that you end up with is the diameter of a lunar or a solar disk on a piece of 35mm film. So, if you're using, for argument's sake, the standard 50mm lens, which a lot of people have, divide that by 100, and what you do, you end up with a diameter of sun which is 0.5 of a millimetre on the 35mm frame, which is pretty small. Now, if you go to, say, 100mm, a bit better, 200mm, better still, 500mm, better still. And then if you go to 1,000 millimeters, you really have a diameter on the 35 millimeter frame of 10 millimeters, which is really quite considerable. But to get that, you have to be using a big Bertha sort of lens of this kind, which of course is pretty expensive and not everybody will have. Now, the obvious thing that one needs to consider next is exposure. We have to emphasize the fact that there's no such thing as a perfect exposure for this sort of work. Conditions can vary so much, the atmospheric conditions, individuals, lenses, the equipment generally, and the degree of capability, of course, varies. So what we can do is to suggest some exposures, but they need to be only regarded as the basis for a whole series of bracketing, in which you bracket by perhaps a couple of stops or shutter speeds on either side. Now, we have a table of this. Down the left there is the speed of the film. We used to call it ASA in the old days, but it's called ISO now. So you see 50 to 64, 100, 200, 400, and so on down the left. On the right are some suggested exposures, f8 or whatever it might be at 1/25th, 100 ISO film, f11 at 125, and so on. But these are only guides, and I think one has to stress that bracket to get some results which probably somewhere or other will be as good as one could expect. Now, does that mean that one can only have results, good results from exotic equipment? No, it doesn't. For example, the sun, when it's being eclipsed, shines through tree canopies. And what happens is that the light coming through between the individual leaves acts as a pinhole camera. And so what we have here, of course, you see the crescent sun beginning to develop. You just point your camera at the ground, photograph it, and you can take a series of close-ups if you want to. So you have really quite a nice record of the eclipse, but pointing downwards instead of upwards, which is quite something, I think. But then you can, with conventional lenses, relatively short lenses, you can get quite exotic, quite sophisticated. If you have a camera, for example, with which you can override the double exposure prevention device and take a series of images on the one frame of film, you can get a sequence like this. But we won't, of course, be able to get something quite as sophisticated as this on May the 10th, for the simple reason that we'll be struggling with the setting sun, of course, going down at the same time as the eclipse ends. And, of course, we will need, it's worth stressing, Patrick, to a completely clear western horizon, because it is going to be the last gasps of the day when the eclipse is occurring.
Well, let's hope for clear skies. And remember, even when the sun's low down, it is still dangerous. Let's go back to our timetable. On Tuesday, May the 10th, the eclipse begins at 6:35 p.m. summertime. Greatest obscuration, as we see here, 7:35 summertime, and it ends at 8:30 summertime, by which time the sun is going to be inconveniently low down. If you want to see a total eclipse, you can, of course, go to Peru next November. But if you stay here, then you've got to wait till the 11th of August, 1999, when the track will cross Cornwall, and that will be quite a day. But later on this month, on May the 25th, we're going to have something else. We're going to have a partial eclipse of the moon. Now, a lunar eclipse is quite different from a solar eclipse. Nothing can get in the way of the moon, because apart from the very occasional asteroid, the moon is much the closest body in the entire sky. It depends, though, upon reflecting the light of the sun, and an eclipse occurs when the moon passes into the shadow cast by the Earth, and the supply of direct sunlight is cut off. And you might imagine from that the eclipsed moon would disappear. But generally speaking, it doesn't, and this is why. Here are the sun's rays, casting a cone of shadow onto the moon with an area of partial shadow to either side. But the Earth is surrounded by a shell of atmosphere, and that atmosphere bends or refracts some of the sun's light onto the lunar surface, and therefore at most eclipses the moon doesn't disappear completely. And there again we have the diagram, the umbra or complete shadow, surrounded to either side by a zone of partial shadow. And in most eclipses the moon turns a lovely coppery color. But this is only a 25% partial eclipse. And this shows what happens. We have here the main cone of shadow, which is the umbra, and as you can see, the moon only just grazes it, although it does go through the partial shadow or penumbra. And to show how that works, we arranged here a studio model. There we have our model sun, there the Earth, and there you can see the shadow cast by the Earth onto the screen behind, and you can see the dark umbra in the middle and the penumbra all round. One other point, by the way, when you have an eclipse of the sun, you have to be in the right place at the right time. But when you have an eclipse of the moon, it's visible from wherever the moon is above the horizon. So from any particular point on Earth, eclipses of the moon are more frequent than those of the sun. So let's have a timetable for May the 25th, again in summertime, and this is an early morning eclipse. It begins at 3:37 a.m., greatest obscuration 4:32, and it ends at 5:23, by which time the moon's going to be very low indeed, and it may have set over most of Britain, I think. But even so, not all eclipses look exactly the same, and you've demonstrated that, Douglas.
Yes, Patrick, you remember in 1991, Mount Pinatubo in the Philippines exploded and ejected an enormous amount of dust and gas into the atmosphere. Well, when we took some pictures of the first eclipse after this, of course, it appeared very, very dark compared with others. This almost looks like Mars, as I'm sure you'd agree. But now we're moving out of that phase. It's 2 years or so, 3 years onwards, and the last eclipse back November was, in most areas, a bit lighter, and one's beginning to move to the area, to the stage again where one has these beautiful exotic colours of light oranges, pinks, and sometimes blues and greens here and there.
Well, let's wait and see. Once again, Douglas, will you explain just how to photograph this partial eclipse?
Well, there's no problem with filters, Patrick, because we're not photographing the sun, of course. With this eclipse, which is partial, the problem is the contrast between the umbra and the penumbra. The film just can't handle it. So, you see, you cannot expose for both of those. You have to decide, is it the umbra or is it the penumbra? With the area involved, I would unhesitatingly say you expose for the penumbra, and I would suggest exposures with a 400 ISO film. Here's a similar sort of picture. I would suggest that exposure of, say, 125th at f11, but it will be important to start bracketing again. But the thing that those pictures remind me of is that we're dealing with nature all of the time, how man can intrude. And we were talking about that annular eclipse in California in January of 1992, a little while ago, Patrick. And I remember that as we started to photograph that eclipse as it progressed, enormous numbers of balloons went up in the air. And one was looking at these, there were about 20 at least, and thinking, oh my God, they're going to be in front of the sun all of the time. But by the time we started to really get to work and close to annularity, they'd all disappeared except for one. And it was in the perfect position to make the sort of composition which I would suggest one only not quite tends to get once in a lifetime, but is pretty rare anyhow.
I don't think you'll get that again. Douglas, thank you very much.
My pleasure, Patrick.
So meanwhile, let's hope for clear skies for the solar eclipse on May the 10th and the partial lunar eclipse on May the 25th. Meanwhile, if you want the latest astronomical information, then you can ring our Sky at Night information line, 0891 800 330, cost 39 pence per minute cheap rate, 49 pence per minute other times, or you can dial CFAX page 615. Next month, we're going on a special visit. We're going to the Observatory of Edinburgh, the Royal Observatory on Blackford Hill, which is 100 years old, and we're doing a special centenary program from there. So until next month, from Douglas and myself, good night.